Writing a polynomial function from its zeros. We're going to look at a couple of examples of how to do this. So first, we're going to find the equation of the polynomial function in the graph below. So here we have a graph. We're going to start writing our function, f of x equals, I'm going to look at my zeros. So it crosses the x-axis at -3. So that means I have the factor x plus 3. And the function's going straight through the x-axis. It's not doing a little bobble, so I have just an exponent of 1, or I don't even need to write that exponent. Then my next zero is here at -1. So I have a factor of x plus 1. Again, just an exponent of 1, which I don't need to write. My next zero is at 1, so I have the factor x minus 1. Again, the function's going straight across the x-axis, so exponent of 1. And then finally, my last one at 4 gives us the factor x minus 4. Again, going straight across the x-axis and not bobbling. And this is most of our function. We're mostly done, but we don't know the leading coefficient, so I'm going to put a. One more piece of information that we can get from the graph is the y-intercept. And I can see that it crosses the y-axis at 0, 1, or at the point 0, 1. X is 0, 1, y is 1. So we're going to use this to figure out what our a is by substituting in 0 for x. So a times 0 plus 3 times 0 plus 1 times 0 minus 1 times 0 minus 4, and that will equal 1. So if I simplify, I get a times 3 times 1 times -1 times -4 equals 4, or 12a equals 1. To solve for a, I will divide both sides by 12, and I get that a is 1/12. So now we have everything to write our function. So f of x equals 1/12 times x plus 3 times x plus 1 times x minus 1 times x minus 4. And we've not been asked to multiply this all out, so I'm going to leave it in this form. If we were asked to write it in standard form, we would have to multiply it all out. Let's look at example 2. Find a polynomial function with real coefficients. This is implying I'm going to have to multiply out at the end, having degree 4 and zeros 3 plus or minus 2i, and then 4 with multiplicity of 2. So since my polynomial function has a degree of 4, I should have 4 zeros. And I do, because I have 3 plus 2i, 3 minus 2i, and then I have 4 twice. So to start writing my function from my zeros, f of x equals, so my first factor is x minus 3 plus 2i, and then x minus 3 minus 2i. And then my last zero is 4, so I can write x minus 4, and because it has multiplicity of 2, I can put the exponent of 2 on it. So this is essentially my function, but I need to simplify this. So I'm going to start by distributing the negative in these first two factors. So I have x minus 3 minus 2i, and then my second factor becomes x minus 3 plus 2i, and I still have my x minus 4 squared. I'm going to start by multiplying the first two factors together. I generally start by, if I've got complex zeros like I did here, I'm going to multiply the two factors with the i's in it, because if we do it correctly, our I should go away. X times x, I have x squared. X times -3 is -3x. X times 2i is 2ix. -3 times x is -3x. -3 times -3 is +9. -3 times 2i is -6i. -2i times x is -2ix. 2i times negative 3 is positive 6i. Negative 2i times 2i is minus 4i squared. And then that's one big factor, which I can simplify in a moment, and I'm still multiplying by x minus 4 squared. So in that first big parentheses where I did the 9 multiplications, let's see what we can simplify. So I have one x squared term, so I just have x squared. I have negative 3x and another negative 3x, so minus 6x. My 2ix's cancel. My 9's, I have 9, so plus 9. And my 6i's cancel. And then I have negative 4i squared. But remember, I squared is negative 1, so this is negative 4 times negative 1, or plus 4. So that's essentially the first factor. And then I still have my x minus 4 parentheses squared. Okay, let's combine the 9 and the 4 in the first parentheses. So I have x squared minus 6x plus 3. And I'm going to multiply out the x minus 4 squared. I'm not going to show it. By now you've seen this enough times. We're doing x minus 4 times x minus 4. And we get x squared minus 8x plus 16. Now I'm going to multiply my first trinomial by my second trinomial. So again, we're doing 9 multiplications. So I have x squared times x squared is x to the 4th. X squared times negative 8x is negative 8x cubed. X squared times 16 is 16x squared. Negative 6x times x squared is negative 6x cubed. Negative 6x times negative 8x is positive 48x squared. Negative 6x times 16 is negative 96x. 13 times x squared is positive 13x squared. 13 times negative 8x is negative 104x. And 13 times 16 is plus 208. And let's combine our like terms. I have x to the 4th. Combining my x cubed terms, I have minus 14x cubed. Combining my 3x squared terms, I have 77x squared. Combining my x terms, I have negative 200x. And I have my constant plus 208. And this is the equation of my function.